With the chapter review for Chapter 2, we'll be going over the types of things you can expect to see on the chapter test. So please pay attention. Of course, they aren't the exact problems, but they're very similar ones. And I want you to be well prepared for the evaluation that's coming up. We're going to start with a picture like this. Obviously a different picture, but still things going on. You'll be asked to identify whether things are true or false, or whether you can or cannot make the following conclusions based on the picture. So yes or no, or true or false type questions. Can we conclude that P, Q, and U are collinear? Well, let's take a look. P is here, Q is here, there we go, and U is down there. Are they collinear? Yes, they are. That would be a valid conclusion. They are all actually on the same line. Don't be afraid to draw in the picture, or at least mark over it. Look very carefully what's going on. Are we able to calculate that angle QRS is a right angle? Let's see. Angle QRS. Is that a right angle? Well, when I look at we're looking kind of at a perspective drawing here, because RS is not in the plane. And when I look at that, I can pretty much say, because of this right angle box here, I know when two lines intersect and are perpendicular, they form all the right angles right there. So yes, that is a right angle. That would be a valid conclusion. Angle PQR and VQU are a linear pair. Let's take a look. PQR and VQU. Is that a linear pair? Oh, it's this angle and this angle. That's a no. They are not a linear pair. What kind of pair are they? They are a vertical pair. PQ is perpendicular to VT. PQ, VT. Are those perpendicular? And the answer is no, they are not. Nothing there to indicate that's a right angle. SR and PU intersect. Oh, this is an interesting one. SR is the vertical line coming out of the plane and then dashed down here. And PU is in the plane. Is there any indication that they are intersecting? And the answer is no. Because again, it's a perspective drawing situation. That dashed line is hidden underneath the plane because it's a pencil going through the paper, essentially. So no, those lines are not intersecting. So reading diagrams, knowing what you conclude off them, that's actually our first part of the test. Rewriting a conditional statement. My shirt today is blue. So a conditional statement, you recall, uses if-then format. So we'd start out with if. It is the shirt I'm wearing today. Then it is blue. There, it's a conditional statement. No judgment on whether that's true or false. That's just a conditional statement. Tell whether a conditional statement is true or false. If it's false, provide a counterexample. Counterexample, typo there. Counterexample. Yeah, let's provide a counterexample. That's fun. All right, so if x equals 3, then 4x equals 12. Is that true or false? Well, if x equals 3, then 4 times 3 is 12. That's a true statement. If a car is red, then it is fast. Is that a true statement? Well, obviously, that is a false statement. What would be a counterexample? I don't know. A red 1984 Yugo is not fast. Or maybe a toy red car is not fast. A toy car that is red is not fast. So you got to come up with something that is a car and is red, but is not fast. That's a counterexample. right? The converse of if it is a collie, then it is a dog. What does the converse do? The converse switches the hypothesis and the conclusion. So it takes this, and it swaps them. So we write if it is a dog, then it is a collie. Again, I'm not asking you to evaluate the truth of that statement. I just want you to write the converse. If I did ask you to evaluate the truth of that, would that converse be true? And of course, the answer is no. The converse is not true. It could be a dog, and it could be a Doberman, or it could be a lab. That's fine. Was the original statement true? If it is a collie, then it's a dog? Yeah, collies are dogs. Writing something as a biconditional. Remember, when we write something as a biconditional, we drop the if and the then, and we insert what phrase in the middle? Not at the beginning, but in the middle. In the middle, we get if and only if is our magic phrase. So two lines are perpendicular if and only if they intersect to form a right angle. So being able to write a statement, evaluate a statement, write the converse, write as a biconditional, that'll all be on the test. Are we using inductive or deductive reasoning based on what's going on? First day I saw 3 birds at the feeder, the next day I saw 4, the next day I saw 5, so it'll be 6 birds a day after. Inductive or deductive reasoning. Am I basing my decision on observation or on facts? Which is it? In this case, clearly we're just basing on observation and drawing a conclusion, so that is inductive reasoning. A scientist notices that every time he combines 2 chemicals, the solution turns pink. They conclude that this will always happen. So we got a scientist now. Must be facts, right? Deductive reasoning? No, not necessarily. The scientist notices every time that he combines the 2 chemicals, they turn pink. He concludes this always happens. So that is inductive reasoning because based on observation, not on facts. If it said something like the scientist notices the chemical properties of 2 different solutions when mixed force it to be pink, according to the laws of chemistry, then that would be a deductive thing. But if you're just noticing it mixes and it gets pink each time, that's a pattern of events. That's inductive. Lawyer cites a statute that forbids speeding. He also notes that you were going 10 miles over the limit. He concludes you broke the law. Inductive or deductive? Clearly, this is a deductive reasoning situation because it's based on facts. It is not based on repeated observations. It's a simple fact and a rule that is being described, so that is deductive reasoning. So be able to distinguish between those in the test. Make the conclusion, decide if you use the law of detachment or syllogism. If it's raining, the game is canceled. It's raining. What can you conclude? Conclusion, the game is canceled. Which law did we just use? Detachment. It is not a long chain of events. It's if A happens, then B must follow. A happened, so B must happen as well. That's detachment. I think you pretty much can figure out what the next one's probably going to be then. If you eat too much ice cream, you will feel sick. If you feel sick, you can't go to school. If you can't go to school, you miss the test. You ate too much ice cream. Therefore, you miss the test. And you have to take a makeup test, which is super hard, which means you wind up failing the class, which means you wind up not passing geometry, which means you wind up not graduating high school, which means if that happens, that means that you're going to be a failure at life and live in a van down by the river and have no friends and wind up old, alone, and very sad. So if you eat too much ice cream, you end up old, alone, and very sad. Yeah, silly, right? Syllogism. And by the way, the words are given to you. You shouldn't have problems spelling them. You can just copy it off what's up there. I realize syllogism is kind of a weird word. So, chain of events. There'll be algebra proof on here. Algebra proof is fairly straightforward. We use addition, subtraction, multiplication, division, distributive, and substitution properties. Usually pretty straightforward. So we start by step 1 and reason 1, which is given. Now on the test, if you do not number your steps, there will be a pretty significant point deduction. Numbering steps is part of 2-column proof. My next step, I'm going to multiply the 3 onto the x and the 5, so that's 3x minus 15 plus 7 equals 4x. Do not do more than one thing at a time. Just one thing at a time. What did we do? We distributed. That's distributive property. Now, please remember that is not multiplication property because it only happened on one side of the equation. In order to be multiplication or division property, it needs to happen on both sides. This only happened on one side. That is not multiplication or division property. Step 3, I'm going to combine terms. Minus 15 and plus 7 can be combined. So that's 3x minus 8 equals 4x. Again, it's just happening on one side. We're combining terms. What property is that? Substitution. That's substitution property. It is not addition or subtraction property because it's only happening on one side. Now what? Well, the 3x has to come join its 4x friend over here. We're going to do that by subtracting 3x from each side. Now, if you want to write in the minus 3x small here, you help yourself out, you can. However, that's not necessary. But I'm left with negative 8 equals negative x. That is subtraction property. Because we did it on both sides. Now I have to divide or multiply through by negative 1. Now, here's one where we could do multiplication property or division property. Honestly, either answer will be just fine. 8 equals x. I'm going to call it division property. Because like we divided by negative 1, we could have multiplied by negative 1 and had the same result. So I'd also accept multiplication property as correct. Now, some people get uptight. They don't want the 8 first and the x second. They want it this way. They want x equals 8. This would be an extra step. It really isn't necessary. If you finish through number 5, I would say you've completely finished this problem and would have full credit. But if you want to do x equals 8, or you need to do symmetric property. So if you're going to switch sides on things, you have to do it in a separate step, and you have to cite symmetric property as a reason why. But if you just finish your step 5, I'd be perfectly happy with that solution. There will be a couple algebra equations that you have to solve and justify on the test. This was a pretty tough one. Some of them will be just a couple steps. Finally, very simple proof. Given m angle 1 equals 45, prove m equals 2 is 45 degrees. So step 1, m angle 1 is 45 degrees. Reason given. Everyone can get that because it's given. That's free. That's a point. Right away, you're on your way. So let's say this is a 4-point problem. You've already got one of the 4 points. Now what? Well, what is the picture? I see what's given in writing. Once I've exhausted what's given in writing, what's given by the picture? Well, angle 1 and angle 2 are what? Are vertical angles. Can't write, apparently. And I can list that as a given by picture. If you want to say definition of vertical angles, that'd be okay as well. But given by picture is pretty much what's going on. The picture is giving us that. What does it mean? What do we know about vertical angles? Angle 1 is congruent to angle 2. Vertical angles are congruent. Kind of shortcut there. Vert angle using the symbol. Vert angles are congruent. What do we mean that they're congruent? It means they have equal measure. So M angle 1 equals M angle 2. That's definition of congruent. M angle 1 equals M angle 2, but M angle 1 is 45. So I could change this M angle 1 down here into this 45 up here. That's substitution. And we're basically done. I'm not going to make you switch it to M angle 2 equals 45 to look exactly like that. It's saying the same thing. Symmetric property is generally a little excessive in most cases. If you want to use symmetric property again there to switch the order, that would be fine. It would be an extra step, not extra credit. It's not incorrect. It's just really not necessary. So one proof like this on the test. And again, if you got the givens and you got something about vertical angles in there, you're probably about half the points already. So don't sweat the proof. I mean, if there are like 30 points in this test and that's 4 of them and you get 2, you're in pretty good shape. So don't spend all your time sweating the proofs. Spend a lot more time worrying about things like law of syllogism, law of detachment, what is a converse, what is a biconditional, how do I write a conditional statement, what can I conclude from a picture. Those are things you want to be spending your time studying and working on those types of problems. Good luck on the test. We'll see you in class.